This is R.D. Sharma solution, class 12th, chapter 12, higher order derivatives, exercises 12.2. So these are the first part of the questions. I mean, there are two different kind of questions in this exercise. Here we have y being given. There is certain things like double derivative which is equated with, say, lambda y. We have to find out lambda. So essentially we have to find out d2y by dx2. And then whatever comes, we have to replace d2y by dx2 by whatever we get from the double differentiation. Y is equal to ax to the power n plus 1 plus bx raised minus n. So first what we will do, dy by dx. First differentiation, a x to the power n plus 1, so n plus 1 will come in front. So n plus 1 minus 1, that is x, and x to the power n differentiation is n x to the power n minus 1, which is we are applying. Now here b minus 1 will come in front, x to the power minus n minus 1. So it will be minus 1 minus 1. So this is the first differentiation. Now we'll go for the double derivative, which is the higher order derivative. A n plus 1 is a constant, n will come in front, x to the power n minus 1 plus b minus n is there. Now this minus 1 minus n minus 1 will come in front, x to the power minus n minus 1 minus 1, that is minus n minus 2 it will be. Alright, okay. So now d2y by dx2, here we have x square with d2y by dx2. So just multiply x square everywhere here. Now whatever the power of the x are there, we have to add it. So a n plus 1 and n plus 1 is there, x square, and then we have x raised n minus 1, that is 2 plus n minus 1. What is this? N plus 1. So x to the power n plus 1. Here we have negative n and negative n minus 1. So you can just take the negative and make it as positive. So b into n plus 1 it is there. Now add the powers, x to the power minus n minus 2 and x to the power 2. So minus n minus 2 plus 2 it will be. So this gets cancelled. You have x raised minus n, right? So this is equal to lambda into y. So you have to take y here, multiply it by lambda and equate it to whatever we just got. So let us multiply with lambda the y you already have from where we started. So a x to the power n plus 1 and multiplied by lambda, plus here also multiplied by lambda has to be done. So lambda into b into x to the power n minus 1. Let us take this, b into lambda into x to the power minus n. Now this x to the power n plus 1, x to the power n plus 1, you can equate the power, they are similar terms. So a lambda is equal to a n into n plus 1. This is the first equation. Now x to the power minus 1 is also there. In both the sides you can equate this. B lambda equals to b into n plus 1. B lambda is b into n plus 1. So now you have to equate, but both the equations will give you the similar answer. That is, if you try solving it, lambda will be a gets cancelled, n plus 1. And since the question is asking about n lambda only, it is already n plus 1. So there is no use of the second equation for us for this question. Here also you will get lambda equals n into n plus 1 only. Alright. So lambda is equal to n plus 1 is the answer. Now this is the crude way I did it, but actual way I have just represented it now. On the left hand side you can see this is how you have to do it actually. Next one also, as I said, few questions are like this and then the questions will change. So same thing we have to do here. X is equal to a cos nt minus b sin nt. You have to differentiate it twice. It is d2x by dt 2 actually equals to lambda x. So x is equal to a cos nt minus b sin nt. So dx by dt is equal to a cos nt is minus sin nt, and then nt differentiation will also be done. Whatever is inside cos, that has to be differentiated. It will be n because we are differentiating with respect to t. Minus b sin nt will be cos nt, differentiation of nt will again be n. d2x by dt2 will do. We'll differentiate this content again. So minus a into n, this one. Sin nt is cos n, and differentiation of this nt again will give you n only. So I am making it as n square. Similarly here b, cos is minus sin t, so I have just made it as plus. Nt, differentiation will be n. There is already an n, so we have n square. So this is d2x by dt square. And it has to be equated to lambda into x, as we just did in the previous question. We have to multiply it by lambda, the x content. What is x? A cos nt minus b sin nt, and you just multiply lambda with both of the terms. This is equal to minus an square cos nt plus b sin nt into n square. Now you have two equations. You can just equate the similar terms. So a cos nt into lambda is equal to minus a n square cos n. So what it is going to give you, a lambda is equal to minus a n square. A gets cancelled, you have lambda equals to negative n square. In the second equation also, you will get the same term. So lambda is equal to minus n square. Now x is equal to t square, y is equal to t cube. So d2y by dx2 you have to find. Please remember, there is a t term, but you have to find out d2y by dx2. This question we have already done in the previous discussions. So we'll do it quickly. X is equal to t square, dx by dt is simply 2t. But it is y equals t cube. So dy by dt will be equal to 3t square. Now dy by dt divided by dx by dt is equal to dy by dx. You have to find out dy by dx first. So 3t square divided by 2t. What are you going to get? 1t will cancel, 3t by 2. This is dy by dx. Now d2y by dx2 will be equal to 3 by 2 and differentiation of t will be dt by dx. The differentiation of this dt by dx, see, dx by dt is 2t, but we have to put the value of dt by dx. So you have to write this 2t in the denominator. So you get 3 by 4t. X is equal to 2at, y is equal to at square. A is a constant. So we have to find out d2y by dx2 at x equals to half. So dx by dt will be equal to 2a. Similarly, y equals at square dy by dt is going to be equal to 2at. Now dy by dx will be dy by dt divided by dx by dt. So 2at divided by 2a, you will get t. So dy by dx will be equal to t. So d2y by dx2 will be equal to what? dt by dx. And what is dt by dx? It's, see, dx by dt is 2a, so dt by dx will be 1 by 2a. So it will not be 2a, but it will be 1 by 2a. As I am suggesting, we have to write dt by dx, not dx by dt. But at x equals to half, nothing will come because there is no x we have. It's a constant. 1 by 2a is a constant, so there is no point in discussing about x equals to half. X is equal to ft, y is equal to gt. And these are just functions. So the proof and the different theorems we have done, you just have to do it like that. There is no constant, etc. d2y by dx2 you have to find out. So x is equal to ft, y is equal to gt. dx by dt simply we don't have anything, so we'll just write f dash or f prime t. Y dy by dt will be g prime t. Now dy by dx will be what? dy by dt divided by dx by dt. So take the dx by dt and put it in the denominator of dy by dt. So dy by dx will be g dash t divided by f dash t. What will be? This is of p by q form, so if we want to differentiate it again, we are going to use the quotient rule. So it will be f dash t whole square. F dash t will come here in the first place. Differentiation of g dash t or g prime t will be g double prime t. So g double prime t minus g dash t will be like that only. The f double dash or f double prime t. Now you cannot stop here because you are differentiating with respect to x, but we have a t or everywhere on the right hand side. So you have to introduce dt by dx as I just suggested you in the previous discussions. So dt by dx is what? It is dx by dt is f dash t. dt by dx will be 1 by f dash t. So f dash t is already there, so you just make it as a cube. This whole terms goes or boils down to f dash t cube. This is your answer. Now y is equal to 1 minus x plus x square by factorial 2, and this series goes on, and we have to find out d2y by dx2 in terms of y. So this is simple differentiation. Just differentiate it twice and you will get y again. I'm telling you the answer is y. Will you be able to solve it? The solution is in front of you, the reference, but I'll do it for you. dy by dx, 1 is 0. I'm differentiating it directly. Minus x, it will be minus 1, plus this is factorial 2 in the denominator. We don't have to do anything to this. X square will be 2x by factorial. Here minus, you have x cube as 3x square divided by factorial 3. You have x to the power 4, it will be 4x cube divided by factorial 4, and this goes and on for infinite times. d2y by dx2, let us differentiate it again. Minus 1 is constant, so it will go. 2x divided by factorial 2, x will go, so 2 by factorial 2. And minus, we have 3. X square differentiation is 2x, so 3 into 2x it will be. Divided by factorial 3 plus 4, we have 4. So x cube differentiation will be 3x square. So 4, this is 12x square by factorial 4, and this goes on and on. Okay. Now what do you see here? We have to write it in terms of y. How are we going to get y? Because this is a series. But if you see it very closely, 2 by factorial 2 is what? 1. This is the first term in y. Just write it. 3 into 2 divided by factorial 3. 3 into 2, factorial 3 is 3 into 2 into 1. So it's just same. That is only x will remain, negative x. What about 12 by factorial 4? 12 divided by factorial 4 is 4 into 3 into 2. So 4th is a 12. You get it cancelled, it will be 1 by 2. That is, you can just write it as x square by factorial 2. And this goes on and on. And what is this term? This is nothing but y from where we started. So d2y by dx2 is nothing but y only. So d2y by dx2 in terms of y is nothing but is equal to y. Alright. Y is equal to x plus e to the power x. We have to find out d2x by dy square. So there is a trick or catch here. We don't have to find out d2y by dx2. It is d2x by dy. So let us go along with x plus e to the power x dy by dx. So dy by dx it is, you already know how to do the dy by dx. X is 1, e to the power x will be e to the power x. But d2y by dx2, it is there. So this is you have to invert it. dy by dx is already with us, but we have to find out d2x by dt square. So you just invert it or take the reciprocal. So dx by dy will be 1 by 1 plus e to the power x. Now you differentiate it, d2y by dx2 or d2x by dx2. So we'll use this quotient rule. 1 plus e to the power x square in the denominator, 1 plus e to the power x. Differentiation of 1 is 0. Then 1 will remain like that. 1 plus e to the power x differentiation is e to the power x only. So finally it will come as this term is going to be 0. We have a negative. E to the power x will remain as e to the power x because 1 plus e to the power x differentiation is only e to the power x. You can just write it as e to the power x here. Okay. Now it will be negative e to the power minus x divided by 1 plus e to the power x whole square. But what do you see in the answer? It is cube in the denominator. Why? It is because we have to introduce dx by dy term also, because now we are differentiating with respect to y, not with respect to x. We have x on the right hand side, so x should be considered as constant here. So you have to introduce, please remember, dt by dx, which we have done already. It came because we were differentiating with respect to x, not t. Here we are differentiating with respect to y, not x. You have to have a term dx by dy also. This has to be introduced. Alright. Dx by dy we already have. Dy by dx is 1 plus e to the power x. X by dy is 1 by 1 plus e to the power x. So in the denominator we have 1 plus e to the power x whole cube. Negative e to the power x by 1 plus e to the power x whole cube. Y is equal to modulus x minus x square. So modulus x is x when x is greater than 0. Negative x when x is less than 0. So when we remove the modulus, this kind of thing we have to do. So this is a general idea. Modulus x will be what? But we have modulus x minus x square. So y will be positive x minus x square when the x minus x square is greater than 0. Y will be equal to minus negative of x minus x square, that is minus x plus x square, when x minus x square is less than 0. The first thing which I showed you, modulus x, same thing we are going to do here. X minus x square has to be greater than 0. Here, negative x plus x square, it will only happen when x minus x square is less than 0. Now you take one term. X minus x square is greater than 0. That is x into 1 minus x is greater than 0. So it is greater than 0 when both are positive, both are negative. Plus into plus is plus, negative into negative is plus. So it will only be greater than 0 when x is greater than 0 or 1 minus x is greater than 0, or when x is less than 0 and 1 minus x less than 0. So in the first term we get x greater than 0, and if you take x on the right hand side, that x is less than 1. Here in the second term x is less than 0 already. 1 minus x, for that you get x is greater than 1. So x is greater than 1, x is less than 1. No, you would like to understand it very, very keenly, because I am going to make a number line and you will see this. If you take the intersection of all these, x greater than 0, x less than 0, x less than 1, x greater than 1. If you take the intersection of this, you will get a proper relationship. I'll just show you. Same thing will be done for x minus x square less than 0. That I'll leave for you. So you have to understand it very carefully, right? Now you see, we have to take the intersection of all these. X greater than 0, x less than 0, x greater than 1, x less than 1. What are you going to get? So this seems to be impossible, but let me show it to you here. Okay. So x greater than 0, what does it mean? X is 1 is greater than x. So this is the condition. X is greater than 1. That is this x is greater than 1. So on the right of 1 we are talking about, and x is less than 0. So if you take the intersection, this area will come. So x has to be between 0 and 1 in order to get x minus x square as positive. So x has to be between 0 and 1. So I hope you got the idea. You will be able to do that negative x plus x square. That is, in between 1 and 0, it is going to be positive. So below 1 and above 0, it is going to be negative. So this will come as x greater than 1 and x less than 0. So these two conditions you have to write every time. So let us now differentiate it. The only thing which is remaining is just differentiation right now. So we'll do it separately. But these conditions which I just showed you, you have to write it again and again. So dy by dx is simply the way we have been doing up till now. Dy by dx of x minus x square is what? Dy by dx of minus x plus x square is what? So dy by dx of x minus x square is 1 minus 2x. This is going to be minus 1 plus 2x. We can write it like this, and then d2y by dx2 is what? See, d2y by dx2, I'm doing both the terms again. So this is going to be minus 2, and the minus x plus x square was minus 1 plus 2x for the first differentiation. Second differentiation, you're going to get 2. Y is equal to modulus of log x. Find d2y by dx2. Now for this question, you have to know when log will be positive, when log will be negative. And that discussion has been carried out, has been done quite a lot between you and me. Alright. So y will be log x if x is greater than 1. Y will be minus log x if x is less than this. So this log modulus will open with positive or negative, but depending upon what are the conditions. For example, we know all log x will be positive for x greater than 0, and minus log x will always be between 0 and 1. This we already know. If you want to understand it like this, y is log ex, so e raise y is equal to x. So what is the condition here? Whatever you give, because you have to put some, y will be negative, then x is greater than 1 will give you log x as positive. X between 0 and 1 will give you negative log x. So this is the other way to understand also. Alright. So I hope you got the idea. This we have discussed many a time. So I'm just leaving it for you. And I can give you just a short discussion like this. If x is greater than 1, you get positive. If you have x between 0 and 1, log will be negative. Just differentiate it. Log x is 1 by x, minus log x will be minus 1 by x. And these two conditions you have to write it again. d2y by dx2 will be what? 1 by x will be negative 1 by x square. This difference, 1 by x, sorry. And this is going to be minus 1 by x square. These two conditions you have to write. And this is how you are going to present it in your examination. So log x, positive, negative, exponential, positive, negative. When they are sin x, positive, negative, you have to know about that. Okay, this is all about this discussion. Thank you so much and take care of yourself.